Okay, guys, let's go ahead and talk about the warm-up so we can get to just a couple more things for practice, and then I do have an assignment for you today. It is a card sort on Desmos, similar to the last one, but it has a lot more graphs. So it's going to be a similar process, but it's probably going to take you a little bit longer, and the graphs, of course, now are a little bit trickier because now we have to incorporate acceleration. But let's go ahead and take a look at the warm-up first. It says a car starts from rest and accelerates uniformly over a time of 5.21 seconds for a distance of 110 meters. Sketch the xt, vt, and at graphs and calculate the acceleration of the car. So if we want to do those things, I'm going to go ahead and bring the MyOpenMath screen over here for the sketches. Okay, so if you want to sketch this graph, so this car starts from rest and is moving forward, and I know that because it is even labeled positive 110 meters. And so I want to show an object that is moving forward and getting faster. Okay, and so if I want to show that, I need to have a positive slope on my xt graph, and that slope needs to get steeper. But it does need to have a curve. And right, it says up here to ignore the numbers, just sketch the shape. The numbers are actually on there to scale, so you could draw it exactly right if you had all the details or wanted to. But all you need to do is something like that. Okay, it's not perfect, but you can use your stylus for this one because it is a curve, but something that gets steeper over time. Okay, just the right shape is all you're looking for. So again, that would be how you would sketch your xt graph. It's moving forward, it's getting faster. Okay, so it's a positive slope, that's forward. It needs to get steeper, that's faster. Okay, number 2 says to sketch the vt graph for this motion. Again, all forward motion is up here, all of it. So if you're moving forward, it's going to be up there. Okay, and if I want it to get faster, then I need it to get farther away from 0. Okay, farther away from the x-axis. Yes?
On the one above, shouldn't it like stop at the 5?
Yes, it should. I told you you could ignore the numbers though.
Oh,
so
okay.
it's, I mean, yes. If you wanted to draw it more precisely than this, yes, it should not go that far.
But
Should.
don't ignore the numbers on the card sort.
Yeah, the card sort's just shapes. There aren't any numbers.
Oh, okay.
Okay. But again, here, VT graph, it says that we're assuming that our x-axis is in seconds. So this is time in seconds. And then this is in meters per second. Oop, well, don't do that. Okay, so again, if I want it to go forward and to speed up, it needs to be in the positive region. If it starts from rest, I'm going to start at the origin, and then something like that. Okay, again, you can draw it correctly if you want. I did not look at the actual numbers in the question. I'm just drawing the shape. Okay, but something like that. Okay, and then this last one, the AT graph, again, your acceleration, you can find your acceleration simply by looking at the slope of your VT graph. This graph has I just realized I can't add anything to it because it's going to connect it, I think. Yep, can't do it. But that has a positive slope. And so if I have a positive slope, I need to have a positive acceleration. And it's a constant acceleration, so it should be a straight line. You can actually, instead of trying to draw it, you can click and drag and it'll be straight, and that's fine too. But you want it to be a straight horizontal line above the x-axis to show that it's positive. And again, I'm ignoring the numbers here. If I actually calculated it first, I could actually put these where they're supposed to be. But I just want you to get the shapes. I don't want to complicate it right now by adding the numbers into the graph. Okay. Does anybody have a question about that portion of the warm-up? Okay, then let's go ahead and do the calculation. Okay, calculate the acceleration of the car from that scenario. So let me go back. That's not what I meant to do. Back here, because I have the graphs here and I have the calculation here as well. So again, this was the shape of our graphs. Okay, but the calculation of the car, again, you're going to want to start by labeling the information that you're given. Okay, you have to start there. Really, it's the best way to start because otherwise you are looking at 4 different equations and you're not going to know which one to use. Okay, so if I want to start by labeling my given information, I am given the initial velocity. Does anybody know where that is in that question?
0.
I know it is 0, but why is it 0?
Rest.
Because it says from rest. Okay, so make sure that you recognize that those words as being information that you're given. If it says starts from rest, they gave you initial velocity of 0. If it says comes to a stop, because some of your questions said that in your My Open Math assignment, that means your final velocity is 0. Okay, so sometimes the information that's given to you is in words. You have to look for those words. Okay, but starts from rest means my initial velocity is 0 and accelerates uniformly over a time of 5.21 seconds for a distance of 110 meters. Okay, so I am given initial velocity, time, and delta x, my displacement. Okay, and so with that information, I'm trying to calculate the unknown here is acceleration. So those are the variables that I'm looking for in those equations. And there were 4 equations that we looked at. These are them. Okay, so looking at the information on my screen, I need to find VI, T, delta x, and A. Okay, so if I look at equation A, for example, I cannot use this equation because I do not know VF. Okay, can't use A. Which one can I use? There you go. Okay, so that is the hardest part, is just figuring out which one to use. Because from there, I'm hoping y'all can just type in the numbers to solve it. Okay, but equation C would be the best one to use here because it has the information that I have. And it will allow me to solve for the thing that I need. Okay, so that's the equation. Notice it doesn't say A equals, but it doesn't matter. Once I plug in, I can rearrange it. Or if you prefer, you can rearrange it. You can manipulate that equation before you plug in. It doesn't matter. Okay, but we're going to go ahead and substitute into it. Okay, like this. 110 equals 0 times 5.21 plus 1/2 times A times 5.21 squared. Okay, that's just straight substitution. So now we can start to do some of the math here. For example, 0 times 5.21 is going to be 0. So that's going to go away. Okay, and then 5.21 squared is 27.1441. Okay, so that's what I have there. Again, get rid of that. I can now multiply these. Half of 27.1441 is 13.57205. I'm leaving all the decimals on here right now. I wouldn't normally be writing all of them out. I just do it in the calculator. But do not round until you get to the end. Otherwise, you might have rounding error at the end. Okay, so now I've got this. And now it's easy to isolate this variable A because all I have to do is divide because these are being multiplied. So divide both sides by 13.57. Keep going. But you have 110 divided by that number gives you A, and when you put that in the calculator, you get 8.10 meters per second every second, or meters per second per second. Again, if you look at the units, you can see where that came from, because this over here was times squared. Okay, so that's second squared. Whenever I squared, I also square the unit. I just didn't write the unit. So it becomes meters divided by seconds squared, which is the same thing as this. You could also write it as meters per second squared. All right, so 8.10 meters per second every second, or meters per second squared, would be the acceleration. It is positive, which makes sense because it is accelerating from rest forward. Okay, any questions about the warm-up? By the way, go ahead and type this number in on Schoology, along with the units. I think you have to type those too to get your credit. Okay. Do you have any? Do you have a pass, Kennedy? All right. So before we move on to the card sort, I just want to make sure we're comfortable with the graph. So on my screen, I'm going to give you either one graph or a description of some motion. And guys, I'm going to ask you to take out some paper right now because I'm going to see how you guys do with this. Okay. So I have given you a VT graph, and I would like you to sketch what the XT and AT graphs would look like that match the motion shown in that VT graph, because that's basically what you're going to have to do in the card sort anyway, except you're not having to draw them there. But I'd like to see if you can draw them here. So again, I've given you a VT graph. I would like you to show me what this looks like as an XT and an AT graph. So if you could just sketch this on your paper real quick, and then we'll look at this one, and then we'll move on to the next one. I've got, I think, 4 of these or something up here, and then we'll do the card sort. Okay, so again, go ahead and see if you can draw these out. I'll give you a moment to try this. If you're not sure, check with your neighbor and see if you can help each other figure it out. Okay, so I'm hoping you guys were able to figure this out, but looking at this graph, you need to ask yourself, what is this object doing? Okay, this object is moving forward and it is getting faster. So your graphs just need to show something that is moving forward, getting faster. For my XT graph, that means I'm going to need a positive slope that gets, I don't have them on here, sorry. That means I'm going to need a positive slope that gets steeper, something like that. Okay, if you follow my cursor there. And for my AT graph, all I have to do is look at the slope of this. This is a positive slope, so I would have a horizontal line up here in the positive region of my AT graph. You guys get that? Awesome. Okay, let's try this one. Okay, here is an XT graph. See if you can draw the VT and AT graphs that would match this one. Okay, so I'm going to draw them on here because I thought I had them on my computer and I don't. So I will draw these two. But I'm going to give you guys a 29-second timer. So you can try this, turn to your neighbor if you're not sure, help each other. All right, let's go ahead and I'm going to switch over to my screen, my document camera for a second. So this is pretty much what the XT graph looked like. So again, you're asking yourself, what is this object doing? Looking at the shape of that graph, you should know that that object is moving backwards. And I know that because it has a negative slope. Okay, and that it is slowing down. And I know that because the slope is getting flatter. Okay, it starts out steep and gets flatter. So if I want to show something that's moving backwards and slowing down on a VT graph, all backwards motion is down here. Okay, so it has to be down there. Okay, and if I want to show slowing down, I need it to get closer to 0, because if I get to 0, I have stopped. So as you approach 0, you slow down. Therefore, it would look something like that. Okay, something like that in the negative region, getting closer to 0. Okay, now if you didn't have that, you probably have this wrong. We'll see. Okay, but if now that you see this, what do I need to have over here for my AT graph? What's the slope of this line? Positive. Okay, I have a positive slope here. Therefore, I have a positive acceleration. Okay, let me show you with some numbers real quick, because this is the one of the situations that is a very common misconception. If you were to look at a table of velocities and time, so let's say we have 1, 2, 3 seconds, okay? Velocities, if you are moving backwards and slowing down, your velocity might start at, like, let's say -10, and then it'll go to -8, and then -6, and then -4. Okay, what is the change in velocity each second here? +2. Okay, this change is +2. The acceleration is +2 meters per second every second. So even though this object is going backwards, these are all negative numbers, my velocity is negative, my acceleration is positive. Okay, and when these signs are opposite, when you have a negative velocity and a positive acceleration, that's when your object slows down. We talked about that as well. Okay, so sometimes it helps to see it with numbers, but that's what this is showing. It's starting at -10 and then -8 and then -6, and for example. Okay, but that is a positive change, therefore your acceleration is positive. Okay, so if you need to, you can even sketch down out a table, yes?
Does that mean when the acceleration is negative, the velocity is positive?
No, it's not always true. You can have positive acceleration with positive velocity as well. The first one actually was. The first example we just looked at a second ago with this one, okay, that was positive acceleration and positive velocity. Okay, so you can have any combination of them. You can have negative velocity, negative acceleration, positive velocity, positive acceleration, or you can have negative acceleration, positive velocity, positive acceleration, negative velocity. Okay, so all of those are possible. All right, let's go ahead and take a look at the next one. Okay, here is a VT graph. See if you can draw what this would look like on an XT and an AT graph. And I'm hoping You guys are figuring these out as we go. If not, then you're going to have to figure them out on the card sort, but I just set a timer for you. So if you're not sure, turn and ask your neighbor, and then we will talk about it in just a second. Okay. Do y'all need another moment? No? All right, so here is what we're looking at now, okay? All right, so I have my VT graph down here. This is in the negative region of the graph because this is 0. So my velocity is negative. Is it changing? No, I have constant velocity that's negative. Okay, so I don't have any acceleration here. Okay, I'm actually going to draw my AT graph first. The slope of this is 0. Okay, I don't have any acceleration, so my acceleration is going to be 0. It's going to be on that x-axis. Okay, but for my XT graph, what direction is this object going? Backwards, okay, because it's in the negative region. It's backwards, but it's constant. If I want to show constant velocity backwards, I just need a straight line with a negative slope. Okay, this is a graph that you would have done in Unit 1. Okay, that was probably in your last card sort that we had. Okay, but that's constant velocity backwards. Questions about this one? Okay, let's see what the next one is, because I think I have 1 or 2 more. Draw the graph for an object that is moving forward and slowing down. So this one I just gave you a scenario. I'd like you to draw what that would look like if you are moving forward and slowing down. So again, you can talk to your neighbor if you're not sure. Okay, so forward, slowing down. And you can start with any of these, but I'm going to go ahead and start with the XT graph. Okay, if I want to go forward on an XT graph, I need to show that as a positive slope. That's not what you're going to draw, but that's my positive slope. It needs to go in that general direction. It's not going to be a straight line, though, because I need to show that I am slowing down. Okay, so if I need to slow down, my slope needs to start out steep, and it needs to get flatter. Okay, that is how you show slowing down, is your slope is going to change. It's going to get flatter. But you're going to have an overall positive direction to the slope. So that's forward, slowing down. Any questions about the XT graph? All right, VT. Forward, slowing down on a VT graph. Again, forward is up here. So my line is going to be in the positive region of this graph. But if I want to slow down, I need to move toward 0. 0 is the x-axis. So I'm going to have something like this, forward slowing down. Okay, and then to draw the AT, honestly, I think it's easiest to go to AT from the VT, because all I have to do is look at the slope. Positive or negative? Negative. That's it. Okay, the other way that you could do this is you could say, okay, if I'm moving forward, that means I have a positive velocity, because it does. If you're moving forward, you have a positive velocity. Slowing down means that my acceleration has to be an opposite sign from my velocity. That's the other way to do it. Okay, so you can either use the slope of this to get this, or you can say, oh, if I slow down, these have to have an opposite sign. Okay, either way, whichever one you find easier. Okay, but that's still what you're going to end up with, is something in the negative region of the acceleration time graph. Does anybody have a question about those? Okay. All right, so then what I'm going to have you guys do is I'm going to have you complete the card sort. It is assignment 203, acceleration card sort. It is linked in Schoology, but it's going to take you to Desmos. So you can go to Schoology and click on it, or if you're already in My Open Math, it's linked there as well. Just make sure you click on first period because they have a different Desmos class for each class period, so please make sure you click the right link. Some tips for the Desmos. You're going to want to zoom out, okay, because I'm telling you right now this has more cards than the last one, and so it's going to look really messy whenever you open it up. So zoom out if you can, and then what I would start by doing is the same thing I recommended last time, group the cards by type. So put all of the XT cards together, all of the VT cards together, all of the AT cards together, and then once you have it organized on the screen, it'll be a lot easier to look at. And remember, if you group them like that, you can collapse them. Like if you're like, oh, the one I'm looking for is not here, collapse it, and then you don't have as much of a mess to look at. So anyway, that is what I would recommend that you do to start, is by grouping them together before you match them. You are trying to match an XT, a VT, and an AT graph together. And so that is what I have for you for the rest of the class. If you think you have it right, you can ask me and I can tell you, yep, that looks good, or no, you don't have that right yet. And then when you're finished, I would work on the unit summary, some practice in that because you guys have a CFU tomorrow. So there's an acceleration CFU in My Open Math, and those are the ones that are more like a quiz where you don't have all of the multiple chances for partial credit. So make sure you feel comfortable and ready for that. We did some math yesterday. We did one calculation today, but if you're still uncomfortable with the math after all of that stuff, then you're going to want to look at some more of that. And the unit summary is a good place to start. It's going to have, some stuff with graphs. So definitely look at those things. And you can, if you did not finish yesterday's My Open Math assignment, you're now in the late window, so make sure you get that done. But that is there as well. So prepare for that CFU tomorrow, work on the unit summary, but first go ahead and do the card sort, 203 acceleration card sort in Desmos. If you have questions as you're working, please let me know. I'd be happy to come over there and look at it with you. I'd recommend that you work with a neighbor or something as well. You can obviously finish it at home since it's digital.